Okay, here's three law question. The first one is Newton's law of cooling. So here's the formula, and that's the stuff we have to plug in. N temperature at the end. T1 is the temperature that it starts with, and T0 is the temperature of the environment. Let me just see if that's right. Surroundings of temperature, yeah. And then K would be the cooling constant, and T would be the time. It's minus, and so that means the temperature's dropping. Okay, so they say a chilled jello salad with a temperature 42, so that is what goes into T1. Let me just write my formula down. T0 plus T1 minus T0 e to the minus k times T. So T1 is 42. Placed, so it was in the fridge, and then they took it out at 68. So this is 68 of the surroundings, minus 68 e to the minus, I don't know what k is, but they say after 10 minutes, so that's T, the temperature of the salad is 48, the end temperature. So that's this number over there. Okay, now I need to solve this. So to solve this, the first thing I'll isolate this. So I'll subtract 68 on each side. So minus 20 is equal to, and then 42 take away 28 is negative 26 e to the minus 10k. Okay, just like we've solved other equations, I'll divide both sides by negative 26 to isolate that part. So I'll get 20 over 26 is equal to e to the negative 10k. Change to log form. So log base e of 20 over 26 is equal to negative 10k. So the ln, that's a 6, of 20 over 26 divided by negative 10, it's a 6, is equal to k. Okay, calculator. Whoops. So ln, where's my ln, of 20 divide 26, close my bracket, divided by negative 10. Okay, so the constant of cooling is negative, positive 0.0262364. I'd like to use quite a few decimals there. Okay, so that gives me my constant of cooling. But then the next question is, use Newton's law to find the salad's temperature after 20 minutes. So if I'm looking at this formula again, they're saying what is the temperature after 20 minutes if you use these same numbers, right? So 68 is the surroundings. It comes out of the fridge at 42, minus 68 e to the negative, but this time I know what k is. My k is 0.026.2364 times the time, which this time they say how long, what's the temperature after 20 minutes. There we go. And now I can just plug that into decimals. Let's do that. Oops. Okay, hopefully this will work. All right, so 68 plus bracket 42, delete, come on. There we go, 42 minus 68 bracket e to the, in brackets, negative 0.02, no, 0.0262364 times 20, bracket. So 52.6. So the temperature after 20 minutes will be 52.6. And if you look at it, it makes a bit of sense, because if it came out of the cooler at 42, the temperature in the surrounding air is 68, then it's just going to keep warming up, right? And so 52.6 makes a bit of sense. Let's try another one. Okay. Following the birth of a child, the parent wants to make an initial investment that will grow to $70,000 for the child's education at 19. Interest is compounded continuously at 5%. So if it says continuously, then I know I want to use this formula, P0e to the kt. And so they want to know what that is. So they want to know what P0 is, but they want to get $70,000 out of the deal, and that's this number. So 70,000 is equal to P0, they don't know, E to the growth constant, they say it's 5%, right? Where did I see that? 5%. So K is 0.05 times, so they're born and they want to have 70,000 by the time they're 19. So the time is 19. So here I need to solve for this. So basically, I can just divide, since I'm looking for that, divide both sides by e to the 0.05 times 19. Divide e to the 0.05 times 19. So I just need to do that on a calculator. Let's try that. Whoops. Okay, so I want to go 70,000 divided by e to the, in brackets, 0.05 times 19, bracket. There we go. So if they want to have 70,000 by the time the kid's 19, they need to put $27,071.87 into the bank now, and then by the time they're 19, they'll have 70,000. Okay, one last question. This one, they say given log b of 7 is that, log b of 9, and log b of 16. They want to find the log base b of 1 over 63. So log base b of 1 over 63. And what I want to do is I want to express this so it has all of these numbers. Not all of them, but it has as many as you need. When I look at 63, I know that that's 7 times 9. So I could write this as log base b of 1 over 6 times 9. Not 6 times 9, 7 times 9. 7 times 9. Okay, now this would be, let's use the product or difference laws to figure that out. So that would be the same as log base b of 1 minus log base b of 7 times 9. Now, this I can expand out to. So this would be log base b of 1 minus log base b of 7 plus log base b of 9. Okay, that's a product law. Now, since there's a minus in front, then both of these become minus. So log base b of 1 minus log base b of 7 minus log base b of 9. Okay, that because of that minus. And now we can evaluate each of those. So log base b of 1, anything, if you get a value of 1, let's see. Yeah, the answer to the whole thing there is just 0. So this is saying to what exponent must you raise b to get 1? In other words, what is the exponent here to get a 1 out of the deal? And the only number that you can put in there is a 0, because anything to the 0 power is equal to 1. Okay, so that that exponent, then this thing, value is just 0, minus log base b of 7 up here is 1.96946, minus log base b of 9 is right there, 2.197. So if I do that on the calculator, it'll come out to negative, I don't know, 4 point something. Okay, you can do it on the calculator, but it'll be about that. Okay, hopefully that helps you with those 3 questions.